So I would like to introduce David Taglieri from Epson. He is going to demonstrate the Epson V1070. It is a UV desktop printer, which is everybody getting excited about. Not only that, but how about Braille? So we were just looking at our Braille sample, which everybody is just getting so excited about. So going to give it to David, and he's going to go through some details about demonstrating this printer and what it can do.
Excellent.
Okay, David.
Thank you, Amy. Awesome. So as Amy mentioned, this is a UV printer. Predominantly, it is a CMYK printer with two additional channels, one for white and one for varnish. And the idea is that we could put a pre-white down to get any kind of opacity. So if it's a colored document or a colored item. In regard to today's presentation, we were printing coasters. And I'll give you folks an idea of how we went about doing that. So inside the printer, we have an A4 platen or print space. So that's approximately 8.3 inches by 11.7. And we have a platen that is adjustable in height automatically or manually up to 70 millimeters, which is approximately 2.75 inches. So we have the ability to do something that has dimension to it. And then more importantly, what Amy was showing with that signage is we're able to create a tactile finish or feel simply by building up layers of, in this case here, it could be white with a varnish on top, or it could be colored with white and then a varnish on top. And the idea there is that we could start to create either texture values to the printed piece, or in certain instances, actually create any kind of tactile feel for legibility, which we were showing there. So because it is a UV printer, one of the nice features is we utilize an LED lamp system. So as the carriage passes passing, not only applying the color, but we're also curing that UV ink on the fly. So what we end up with is not only a printed piece, but the ability in some instances to actually print over something. So if we're doing alignments, and that's what we're going to talk about next, how do we center or how do we set up or create some type of temporary jig or fitting system for the different types of pieces that we'll print. In this instance, I'll show two different examples. One is mechanically, you could physically build something. So in this regard, we just took the surface area, and then for the sizes of each one of those slate coasters, they could actually wedge and fit underneath each one of these screw heads. So we're kind of getting a square piece. You could see that there was lines drawn. In some instances, this could be done on 3D print technology as far as building something that looks more official. But in regards to today's presentation, it could be something as rude and simple as just a plain piece of paper down on the platen. So that's what we're going to show here, is simply by putting the platen and putting this protective piece of Mylar on top. I've actually put crop marks around each of the four edges. And what that allows me to do is, without using that jig, take new blanks. In this case here, it is a natural stone. So the recommendation would be to prep the surface and wipe it with an isopropyl alcohol and a cloth-free wipe. There are additives that can be added to any kind of substrate that's rigid to create an additional bond. So ideally, the inks have a certain rating of dyeing that allows it to adhere. So there's markers that you could test on the surface of different substrates to determine what that dyeing level is. And then more importantly, there's additives that you could wipe on this surface that will allow that attraction to be more applicable for your use. So what I'll do is go ahead and eyeball, again, because these are natural, not every one is going to be exactly square. So the idea of being extremely precise in regards to this application would be less likely simply because it's a natural piece. So what I'm going to do is just ideally set them over each one of these crop marks that I've created. This bed does have vacuum suction, so there's micro holes here that'll actually suck down and draw down the underbase. If not, my recommendation would to be apply any type of light adhesive tape, something like blue painter's tape. Seems to be very common. And by having this material down below, if there's any overspray, if this was not designed or laid out properly, the idea is that all that ink is going to be trapped and caught on that surface, as opposed to you at the end of the shift or the end of the day wiping down and scraping off any kind of paint or, excuse me, ink that will come across. So now that I have that lined up here, while I have the lid open, I'll talk about a few other things. There'll be some examples between this technology and what Paul was showing earlier with the F series of the same product in terms of its footprint and size seems to be very similar. Epson's competency starts with the print head. Our print heads are the brains of the operation. And the most important thing with Precision Core is we have the ability of doing very simple routines that maintain the machine across a lot of different series of product. So if you're utilizing one of Epson's current products, there'll be probably a lot of similarities to the interface, touchscreen, the components that we use to do maintenance. In this case here, we have a fabric wiper. We have a parking cap system where the print head will sit. And then we also have a specific area where we force or allow ink to pass through and flush. The ideal situation is that those mechanics for maintenance are being done automatically. There's level indicators here that'll just let you know when those supplies need to be exchanged for new supplies. And the idea is that our competency is the print head is designed to last the life of the machine. So we're not degrading the quality of print over the years of use simply by applying heat to push or pass through any of that ink. We use a heat-free system. So we define it as a simple, smart, and a very clean process. The print head is designed to last the life of the machine. The fabric wiper could be end user replaceable in a matter of 13 to 15 seconds. And we have 140 milliliter ink packs. So these ink packs are chipped in the front. So the actual tray that they sit in could go into any tray, but this ink will only fit by its key code into that unit here.
Right.
So we have white, black, yellow, magenta, cyan, and then varnish. That varnish could come out at different intensity levels. So you could do a matte varnish with about 30% of ink volume. And then we could do something as high gloss as 80 to 90% of varnish and create a very smooth, if not gloss surface. So on this side, we have our inks. Over here, we have what is very unique is this cartridge system that's going to pull out for the fabric wiper is also the same area when we're basically spraying ink. We're always spraying it on the fabric wiper. And because we're using that UV lamp system, we're curing the ink. So cleanup on this product goes right to the fabric wiper. There is no additional waste tank on the product. Now that we have the inside done, when we close down, the system is going to validate two things. On the screen here, I'm in the ready mode, but I have the media height adjustment that could go approximately 70 mils. In this case here, I have the volume, that height adjustment set to auto. So before the printer starts, a sensor is going to look across the top of the platen and it will actually reduce the platen height till that sensor gets a clear reading. And then that becomes the focal point or the actual distance of the gap that we're working under. The closer we are in the gap to the surface of the substrate, the more accurate and the more precise the ink droplet will be. So the closer we are, the register and things like small fonts under 6 point will be accurate. If there's any deviation or any distance, that focal now being further away will create like a soft, like almost like a Gaussian blur around small text. So depending on the application and of course, depending on the media from the smooth and the surface of it, will determine how tight in terms of tolerance for register and repeatability. The print quality here is 1440 DPI. So we're going to go ahead and start this process. I'm going to just hit print here. So what I have, I'm going to just pop this up, you can see. We're using Epson Edge Print, which is our solution. This is a PDF print engine, Adobe print engine. And the ideal situation here is that this gives us the control of where we're going to place the image and what process we want to expose or produce those colors, that varnish and that white. And then most importantly, in how many passes and sequences in terms of image quality. So with all things said, I'm going to go ahead and hit print. You'll hear a tone at the printer. That tone is just indicating that the printer is now capable of starting a print production file. Because it is a mechanical unit, by cueing the print from the pre-press side, it will not start the printer until we manually hit the start cue here. First thing we'll see is that the carriage starts to move. So we're actually moving the gantry, and that gantry will see where those images or where that media is. And now the print head will cause the platen to start to drop down until it gets a clearance based on the tolerances that I have set. Again, this is a stone, so not all stones are equal, and you're starting to see what's happening here. You see how those push forwards? Do you happen to see that in your video? So what happens is one of these, because this happened earlier, one of these coasters is actually higher than the other three, and it caused them basically to push forwards, almost like a shuffleboard. So before that finishes, what I'm going to do now is stop when that unit goes there, realign them here on the jig, and then I'm manually going to just increase that gap height so that doesn't occur. And truth be known, since we're in demonstration mode, is I had this all set up before, and then a customer came through with an actual sample of material and said, hey, can we run this? Which we did. So I wasn't ready to re-engage this part of the presentation, but you're getting to see what it takes to make it work. So now it's in recovery. It basically knows, hey, we stopped the sequence. The printer and the print head will go back to the home position. And I will go ahead and hit cancel. It's going to do it again. Oh, no, it's good. Did you see it just dropped again and you can see the gap open? Got it. What's that? Yeah, yeah. In my world for demonstrations, I love when stuff like that happens because this is real world. This is what's going to happen, and these are the ways that you're going to correct it. Yeah, for sure. So this process is going to be somewhat slower compared to the other machines that I'm familiar with, simply because this is a maker's, image and format size. So this is not designed for high volume, simply because it's a slower process. It has all the mechanics and all the quality to do very, very good work. It just will not do it at the production rate of some of our other technology that's just scaled to a larger size. So we get here up on the screen, we basically get an interface that's showing us the name of the file. We could change and see an image of the file. We would also see the approximate time that it's going to take to produce. We then see the levels of how much ink is left in each one of the bags, as well as how much cleaning cloth is available for the fabric wiper. And what we're doing is we're squirting down the white first. So we're doing the underbase of white, which is going to create the opacity that we need. And of course, the whiteness. So when the color sits on top, you could see it on something like slate. Yes, if you were doing this application and only this application, something like a jig board would make the setups that much more convenient. And you can see I got the placement way wrong because that first one is pushed too high this way. I've said before, when we're in demonstration mode, I wish this had like a little sound effect. It goes, ooh, ah, ooh, ah. Yeah, the print head's going back and forth like it's cheering for, ooh, ah. Yeah. Yeah. Well, if not, you're just staring at something like, okay, yeah. But I was like, they should have like a little thing like, ooh,
Yeah.
ah. They'd be like back in my day, like the pinball machines that as you're playing them, there'd be like the button, the fan button. If you're playing like the baseball one, you could boo the crowd. Boo. Yeah, yeah, yeah. That hockey was the same way. Yeah. As you're playing the oh. So you could clearly see that the placement is too far south on each one of those. And that has everything to do with the bottom template, that piece of material that's on there. I never originally had it taped down. So I'm doing all this by eye and what we did about an hour ago. So Vanessa, you can see how we're printing almost off the back one there. So inside the printer, there's actually a filtration system. And what we're doing is we're taking all the internal air and running it through a filter before it expels outside of the machine. Because this is a UV process, it's highly encouraged to have adequate ventilation. There are specifications of how much air turnover should occur during an hour period, which is not needed for the DTF, which is an aqueous water-based product, simply because this is a UV. So that first pass is white. Now here comes the second pass of color. And again, that color is CMYK. The print resolution is 1440 dpi. Because it is UV and cured, these samples will come off not only 100% dry, but in fact, the longer they sit exposed to UV, the harder that surface becomes. So these UV lamps basically have enough intensity to cure the ink. But in fact, if you take especially like the lawn signs, when they first get printed, they almost want to stick to each other if you start stacking them. Because even though they're air quote cured, there's still a lot of reaction taking place behind the scenes. So in shops that are doing that, any kind of light exposure, like if they leave them on tables for 15 minutes to direct light exposure, the surface actually gets harder because it's still curing. Yeah. And that's not unique to Epson. That's unique to just how the polymers work in the UV process when they're being exposed. Yeah.
So would you not recommend stacking these after they're?
These probably, because of, again, it's that ratio of what we're printing on. It's a porous surface, so for sure the ink is curing. The second is we're not putting down a significant amount of ink, so it'll cure that much more efficient. When you do these large, especially political, blue on one side, red on the other, there's so much ink on that surface that even though the lamp is catching it and curing it, as you stack 50 to 75 on top of each other, no surprises when they're kind of like coming apart. Yeah, yeah. So outside of placement, as far as where that loaded on the platen, image quality looks terrific. And of course, readability at such a small font, my humble opinion, is exceptional. Yeah. So. That beep lets us know that it's finished. And then the last thing it's doing is, I mentioned that there's an air filtration system inside. Before we lift this cover, it will run for a full minute. And this is where it's expelling all the air from inside the unit through filtration before it expels out of the printer. And then again, that's just helped to minimize the amount of off-putting odor that exists. And if you didn't want to wait the second I pop this lid, it just stops that from counting down. In regards to these samples, I'm going to actually just take this entire jig plate and bring it up to the line. I'm going to go this way with it. That's what we had to do. Boom. And truth be known, because this is UV, all of the samples that we were printing that will be considered make ready, we're going to come up with another logo design that's going to print right over this whole thing. Because it's UV, we're going to put white down first. I'm going to come up with oversized solid logos before I leave, and then print anything that we used a second time over. And then basically, because it's UV, I have the ability of putting another whole opaque white and then start all over with color and then just repurpose. All I want to do is make sure I'm covering this, kind of like a tattoo cover. I just want to make sure I'm covering up the space of the old with something new that's dense with color and colorful. And then we'll be able to reuse these for something else, because you can clearly see that they're offset.